Hello everybody. In this video we are going to look at the solutions to the honors Doppler effect practice problems 1. Let's take a look at our first problem. We have a bat at rest sends out an ultrasonic sound waves at 35.0 kilohertz and receives them returned from an object moving directly away from it at 20 meters per second. What is the received sound frequency? So in this problem, we are given the frequency of the source of the sound wave, which is the ultrasonic wave emitted by the bat, and that is going to be 35.0 kilohertz. I do have to convert that to hertz, so that would be 35.0 times 10 to the third hertz. The velocity of the source, which is our bat, is 0 because the bat is at rest. The velocity of the observer, which is the object the sound wave is reflecting off of, is 20 meters per second. And because it is moving away from the bat, its velocity is going to be negative because it is moving away from the source. Now, I'm not specifying an air temperature, so we will assume the velocity of the sound wave is 343 meters per second. Now let's take a quick look at what's happening in the problem here. We have our bat. Can I draw a bat? Let's see here. There's my bat. Here is the source of the sound wave. Right. So what's going to happen is the bat is emitting a sound wave here, and we start off at 35 kilohertz. So it's emitting the sound wave. So for the first part of the problem, the bat is the source, and this object is the observer. Then the sound wave is going to bounce off of the object here and go back to the bat. So for this reflected wave, now this object over here becomes my source, and the bat becomes the observer. So I have to do two calculations here. I have to find out what the frequency shift is for this first part, and then I have to find the frequency shift for the second part, or the reflected wave. So for the first part of it, I know that my frequency of the source is going to be 0. So when I plug this into my Doppler equation, I know that the frequency of the source of the sound wave is 35.0 times 10 to the third hertz. The velocity of the sound wave is 343 meters per second. The observer, which is the object, is negative 20 meters per second, and the source, which is my bat, is 0 meters per second. And when I do that, I know that the object over here is going to observe a frequency of 3.30 times 10 to the fourth hertz. Now for my reflected wave back to the bat. Now this becomes the source frequency because that's the frequency that's being returned to the bat. And the object here now becomes the source, and the bat now becomes my observer. Hey, look, I just made feet on the bat here. So here's his feet. There we go. So now I'm going to plug all that into the Doppler equation again. This frequency now becomes my source frequency because that's what's being reflected back to the bat. My bat now becomes the observer, so I'm going to plug 0 in for the velocity of the observer, and this object here now becomes the source of the sound wave, so I'm going to plug negative 20.0 meters per second in for the source of the sound wave. And when I do that, I know that the bat is going to receive a frequency back of 3.11 times 10 to the fourth hertz. Problem number 2. A truck traveling 16 meters per second south sounds its 720 hertz horn at a car traveling north. The air temperature is 18 degrees Celsius, and the driver of the car observes the frequency of the truck's horn to be 805 hertz. What is the car's speed? So I know that the truck, which is the source of my sound wave, is traveling at 16 meters per second. the frequency of the truck's horn is 720 hertz. The frequency observed by the car is 805 hertz, and the air temperature is 18 degrees Celsius. And we are looking for the velocity of the observer. So I know the first thing I'm going to need to do is to find the velocity of the sound wave at 18 degrees Celsius. So in order to do that, I'm going to use my speed of sound in air formula, and I'm going to plug in my air temperature, which I know I need to convert to Kelvin, so I have to add 273 Kelvin to 18 degrees Celsius. And when I do out that math, I'm going to have a speed of the sound wave at 18 degrees Celsius is going to be 340.7 meters per second. And now I can use my Doppler formula to solve for the velocity of the observer. So here is my Doppler formula, and I want to solve for the velocity of the observer. When I rearrange this formula to solve for V sub O, I am going to get this equation right here. The velocity of the observer is going to equal the observed frequency times the velocity of the sound wave minus the velocity of the source divided by the frequency of the source, and all of that is going to be minus the velocity of the sound wave. So this equation is a little bit more complicated to derive, but if you have any questions about that, just shoot me an email and we can go over it. When I plug all of my known values into that equation, I am going to get a velocity for the observer of 22.3 meters per second. Last problem. I am being chased by an enraged warthog. I have no idea what I did to get that warthog so mad at me, but boy, was he really ticked off. All right. I'm running away from the warthog at 12.0 meters per second, and the warthog is right behind me running at a speed of 55.0 kilometers per hour. If the warthog hears my screams at a frequency of 12,250 hertz, what is the frequencies of the screams that I am emitting as I run for my life away from this really vicious and just downright mean warthog? And we can assume that the air temperature is 20 degrees Celsius. So the velocity of the source of the sound wave, which is me, is going to be 12 meters per second. And because I'm running away from the warthog, I am going at a negative 12 meters per second. I have a negative velocity because I'm running away from the warthog. The warthog's velocity, and he is the observer, he or she, I didn't ask. Maybe that was the problem. The velocity of the observer is going to be 55.0 kilometers per hour, which I do need to convert to meters per second. So that's going to convert to 15.3 meters per second. And that is going to be positive 15.3 meters per second because the warthog is running toward me. So again, even though we're running in the same direction, the warthog is running toward me. So he has a positive, he or she has a positive velocity, but I am running away from the warthog, so I have a negative velocity. The warthog hears my screams at 12,250 hertz. I know that because the air temperature is 20 degrees Celsius, that the velocity of the sound waves are going to be 343 meters per second. And we want to know what the actual frequency of my screams are. So I am going to start off with my Doppler formula. Only this time I need to solve for the frequency of the source. So when I rearrange that to solve for the frequency of the source, I will get the frequency of the source is equal to the frequency of the observer times the speed of the sound wave minus the speed of the source divided by the speed of the sound wave plus the speed of the observer. And I plug all of my known values into that formula. I will get a actual frequency of my screams that are being emitted by me of 12,137 hertz, or 12,100 hertz rounded to 3 significant figures.